Welcome back to Algebra. As we do section 4.4, we're going to be working with more equations, and these equations are going to be becoming more difficult as we go along. So following the steps that we learned in 4.3 will be critical to make sure that we do not forget a step and make any errors. In example 1, we have 3x plus 2 plus 5x minus 7 equals 28. Step number 1 was to combine all the like terms on both sides of the equation, and we see that we have 3x and a positive 5x, and that'll give us 8x, and we have positive 2 and a negative 7. We're left with a minus 5 equals 28. Then we isolate the variable by doing the opposite, and so we're going to, instead of subtracting 5, we're going to add 5 to both sides, and we're going to get 8x equals 33, or x equals 33 divided by 8. And then you're supposed to self-check your answer by going back and plugging that in, and so it'd be 3 times 33 over 8 plus 2, and we're going to convert that so that we have the 8 as a fraction on the bottom. So let me erase that, and to make the step go easier, we want all 8s as denominator so we can add them up. So that's going to give me 16 on the top, remember, 2, and I want an 8 on the bottom. That means there's got to be a 16 on top. 16 divided by 8 is 2. Okay, hopefully you know that step. 5 times 33 over 8 minus, again, I'm going to put that over 8 and get 56 on top, and we final answer of 28. So we multiply that across, we get 99 over 8 plus 16 over 8 plus 165 over 8 minus 56 over 8 equals 28. And if you added 99, 16, 165 and subtract 56, you get 224 over 8, which does equal 28. So we know that that is a solution, and we can go ahead and circle it after we've checked our answer. And then the next example is an example of distributive property. 4 times x plus 5 minus 3x equals 24, and we distribute the 4, and I recommend drawing these arrows so you don't forget, and so you get 4x plus 20 minus 3x equals 24. Combine the like terms, and I get x, and I subtract 20 from both sides, and x equals 4. I go back and I plug that in, and so it'd be 4 times 9 minus 12 equals 24, and it does equal, so we can just circle our solution. Example number 3 is a word problem, and it says that John's mother is 4 times as old as John, and John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. So we're going to be adding John, mother, and brother plus 3, and it says the sum, you'll get 80. Okay, but we got to find out, we can only have one variable in the problem, and everything is related to John, so we'll make John x. Well, since John is x, we'll make that. The mother is 4 times as old as John, so it'll be 4x, and the brother is 2 times as John, so that's 2x plus 3. So I have to have a single variable so I can solve it, and I get 5x, 7x plus 3 equals 80. Subtract 3 from both sides, and I get 7x equals 77, or x equals 11. I'm not done here. This is just John, so we can say, and we'll put it up here in blue, well, if John has to be 11, that means mom has to be 44, and the brother has to be 22. And if that all adds up to 77, which is what our equation is, and then that's our solution. So don't forget to go back and plug those numbers in. All right, example number 4 is talking about converting decimals into fraction form. So if we say that let x equal 2.3, and that's a repeating, well, this is kind of a review that we did earlier in the year, and the first thing we have to do is we have to figure out a way to get rid of the repeating decimals. And to do that, this is in the tens place, So we can multiply both sides by 10, and we would get 10x equals 23.3, repeating. And then we subtract our original equation. And the reason we're doing that is because we're going to get rid of that whole decimal aspect of it. Okay, 10x minus x is 9x, and this is gone, and we're left with 21. So x equals 21 over 9. So it's now in fractional form. It's not fully reduced yet. We can divide by 3 and get 7/3. Okay, so make sure it's fully reduced. And the fractional form, if I had a calculator, I could plug that in, would be 7/3. All right, that's a repeating decimal with a tens place. What happens if I have one that's out to the hundreds place or even further? If I had 7.292929 repeating, okay, well that's the same as saying 7.29 repeating. Okay, and we need to convert to fractional form. This time we're going to multiply it by 100 because I'm talking 200 or a hundredth position. So it's 100x equals 729.29, still repeating. Okay, I'm running out of room, but I subtract my original of x equals 7.29 repeating, and I'm going to get negative 99x equals 722. Divide both sides. Oh, that's not a negative. It's, I don't know why I did that, but it's a positive. Subtract or divide by 99. Okay, just get rid of that thing. It's confused everything here. Divide both sides by 99, and that's our answer. But we have to look and see if we can reduce that. And I'm not really concerned whether you can reduce something that large, so just circle that and we'll be done. If it's an obvious one, yes, but if it's not so obvious, just leave it at that form and we'll accept it. All right, to work on these problems, work slow and meticulously to make sure that you make no mistakes.